guys, here I have come with another explanation of one previous year SCIR-NET question, and that has been taken from December 2013. And this question is about the enzyme kinetics, and for that I have uploaded different videos regarding to that particular topic. You can watch those videos and the links are given in the description box. So let's see the question. Michaelis-Menten enzyme kinetics for a simple reaction involving an enzyme E and substrate S is given by the scheme, and the scheme is given over here. It consists of two-step reactions, and the first step in the first step the rate is determined by the Km, and in the second step the rate is determined by the Kcat. So in that case we have to know the basics of Km and Kcat, so we will see in just a moment. And here they want to know the description of Km, Kcat, and the relationship is provided in the following statements. So there are different 4 statements are given. Out of these 4 we have to choose the right combination. Okay, so what are the statements? Let's see one by one. The first statement is Km represents association constant of enzyme substrate complex. Second statement is Km represents the dissociation constant of the enzyme substrate complex. Third statement is Kcat is the rate constant for chemical conversion of enzyme substrate complex to substrate bound enzyme and product. And the last statement is the Kcat by Km is a rate constant that refers to the properties and reactions of free enzyme and free substrate. So out of these 4 statements, which 2 will be the right combination, right statements? So let's see that. So to conclude the answer, let me start with the common reaction that was taken when we derived the Michaelis-Menten equation. That was the enzyme plus substrate. It will form the enzyme substrate complex, and this is the reversible reaction. Here this is the forward reaction, and the rate of the forward reaction is determined by K plus 1, small k plus 1. And the backward rate of the backward reaction from the enzyme substrate complex to enzyme and substrate is determined by lowercase k minus k1. And once the enzyme substrate complex is formed, then the substrate will be converted into the product and the enzyme will be free, and the rate of this particular reaction is determined by the k2, lowercase k2. Now from this equation we derived the Michaelis-Menten equation, and at the time of deriving the Michaelis-Menten equation we also derived the Km, that was the Michaelis-Menten constant, and the Km represents the amount of substrate concentration by which the reaction will attain half of its maximum velocity. That means if we take a total amount of enzyme from the beginning of the reaction, then at a certain period of time the half of the total amount of enzyme will be saturated by the substrate, and that particular situation is the half saturation or the half velocity of the reaction. Okay, so let's see that. Suppose here 1 2 3 4 5 6 enzymes are taken, and to achieve the half of the total velocity we have to saturate 3 enzymes with the substrate. So these blue things are the substrate and the black things are the enzymes. Okay, so 6 enzymes are here taken. Now this is the situation where the reaction will achieve half of its maximum velocity, and this concentration means total 3 enzymes are representing the Km, by which the reaction is getting V max divided by 2. Okay, so that means that is 2 fate of this substrate. These substrates. Once the enzyme substrate complex is formed or produced, if the binding between these 2, means the enzyme and substrates, are strong enough, then it will be converted, the substrate will be converted into the product either, or if the binding is not that much strong enough, then it will be dissociated from the enzyme substrate complex to the free substrate and enzyme, right? So here it is indicating that from this statement we can conclude that Km represents the dissociation constant, because it is not associated with the association constant, because if the reaction is getting half of its maximum velocity, that means half of the total amount of enzyme is saturated with substrate, right? And if the substrate is bound with the enzyme with the very strong bond, okay, in that case they will either be converted into the product, and if the binding affinity is not that much strong, then it will be from the enzyme substrate complex, the substrate will be released back, okay, and that will be free from the complex. So here from this enzyme substrate complex, if we go in this direction, that means it is dissociating the enzyme substrate complex, and from here if we go to that direction, also it is indicating the dissociation reaction, right? So here we can see the Km represents the dissociation constant of the ES, or enzyme substrate complex. So the first statement can be eliminated easily, okay. So I'm just making it cross. This statement is right. Now come to the feature of the KCAT, what the KCAT is. So the KCAT is actually, it is the amount of it is actually the number of chemical conversion of the substrates by one active site active site of enzyme per time. I repeat, the KCAT is also known as the turnover number. It is the number of conversion of substrate molecule by one active site of the enzyme per time, okay. So here two statements are given about the KCAT. So here it is given that KCAT is the rate constant for the chemical conversion of enzyme substrate complex, okay. It is right up to this, to substrate bound enzyme and product. So it cannot be the substrate bound enzyme, because KCAT represents the ability of the enzyme, how faster it is converting, one enzyme is converting how many substrate per time, okay, how faster. Actually it is determining the rate by which the one active site of the enzyme converting the substrates into the product. So no substrate bound enzyme can be formed. Only way to convert the substrate into the product is the that is the actually KCAT means the once the enzyme substrate complex is formed, the KCAT will determine the rate by which the one active site of the enzyme is converting how many substrates, okay. So that is the KCAT. So this statement is eliminated. So this one will be eliminated. So we are end up with only one statement. Only this one is the left. Okay, so here KCAT by Km is the rate constant that refers the properties and reaction of the free enzymes and the free substrate. Obviously, because as we have seen in the definition that it is actually showing the properties of the enzyme and its reaction ability, right? Because how faster one enzyme can convert the how many molecules of the substrates, and also the Km is also, it is indicating the free enzymes, how much enzymes that are attached and how much is free, okay. So this is all about the statement, all about the explanation, and here we can choose the answer is option B, because S and Q, these two are right statements, okay. So with this statement we can conclude the answer. If you like this video, please share it and subscribe it, okay. Thank you.